Okay, so what we're going to start with today is we're going to start with Unit S, which is dealing with interpreting data and basic statistics. So we're going to start on S1 today. We're going to be dealing with just some basics of graphing. We discussed some of this last week. But what I want you to do is I want you to open up right now into S1, and we're going to look at problem situation 1. It's all in how you look at it. And I want you to read through the basic description there, and the three of you can work together or you can work individually. Answer questions 1 through 5. And I'm going to give you about 4 minutes or so to read through that and just answer those questions quick, and we will talk about those as a group here in just a few minutes. So go ahead and read through problem situation 1. Look at these. The first couple here are just asking you to make some observations. So if you look at the chart, does the slice representing payroll tax seem the same size in both charts? I think hearing your conversation is pretty obvious that it's not the same. Which one looks bigger? Where does the payroll look bigger? Yes, it's because it's up front, and like you said, it's because you see the depth of it. Also because it's closer to you. The perspective being further away, it looks smaller in those 3D charts. Very good. So do you think the charts are misleading? Yep. It's a very good point there. How do you define misleading? And in statistics, there are actually 2 types of misleading. One is factually incorrect. I could give you incorrect information, and that's not the case here. The information is correct, but it is somehow, I just had the word, I'm deceiving. That's the word I'm looking at. Yes. It's correct, but it's deceiving. One of the other things we had looked at last week was if you have that bar graph where you have that little cutoff in the axis, the information is correct, but it looks like this bar is twice as tall as this bar when really this might be starting to number at 1200 or something like that. So, number 2, suppose a group wishes to lobby a congresswoman to vote against an increase in the payroll tax. Which graph would they use? They're trying to make the claim that payroll taxes are high enough. So which graph would support their claim? Saying the payroll taxes are already too large? Okay, if you look at the second one makes the payroll taxes look larger or smaller? The second one's where the payroll taxes are in the back, right? Yes. Yep. Yeah, so the top one, where the payroll taxes are in front, makes them look larger. So that makes it look, if you're trying to make the claim that payroll taxes are already big enough or are already too big, that's the one that makes them look like they're already too big. Now, if you were on the other side of it, if you were saying that you wanted to raise payroll taxes, you would obviously want to use the second one where the payroll taxes are in back and they look smaller. Okay, the real problem-solving question on this one is question number 3. You're given a table with certain amounts of information and a bunch of missing pieces of information. For example, for the first one, individual income tax, it tells you that it is $1,541 billion. But it doesn't give you the percentage. As we go down for payroll or FICA taxes, it gives you nothing. For corporate income tax, it tells you that's 10.6% of revenues. Other taxes include like estate tax, tariffs and imports and export taxes, things like tobacco taxes and stuff like that. It tells us those are 9.2%. And then it gives us the total. It tells us the total is $3,249 billion. And that, of course, is 100%. That's the full amount, the total amount. Now, you notice I stumbled as I was pronouncing it. To me, a more comfortable way of pronouncing this would be, rather than saying 3.249 billion, would be to say 3,249 billion, would be to say 3.249 trillion. I'm guessing the reason they're not doing that is because these two are probably going to end up being less than $1 trillion. So they're leaving it in billions. So now the big question, this is a little bit of a review from Unit 1 in the numeracy. How would we find the missing amounts here? We have 5 missing amounts. Well, probably one of the easiest ones to find would be these two. What would I do for those? Not the income, but the total, right? So for this one, you're going to take the 3,249 billion times 0.106, and that's going to give you this amount. Give us 344.39 billion. So then we can do the same thing for other. What do we get for that one? Anybody get an answer for that one? So 3,249 times, what's the 9.2% going to be as a decimal? .092, there you go. And we multiply those out, we're going to get 298.91 billion. It looks like it says the number should be rounded to the nearest billion and the percent the nearest 1/10 of a percent. So this should probably be just 344. And this should be 299. So now we have those two. The next one, there's 2 others now that would be easy. I'm going to have you guys pick one of the 3 blank spots. Which one can we find next? Can you find the percent for the individual income tax, the percent for the FICA, or the amount for the FICA? Which one do you want to find next? Percent for the individual? Okay, and how would we find that? Right. That should be the amount of the individual income tax divided by the total taxes. Well, what you're dividing by, when you're doing percents, what you're dividing by down here is always whatever represents 100%. So when the total represents 100%, that's what we divide by. So 1540 divided by 3249. So 47.4% that looks like. Now the rest of this is pretty simple. How do I get the dollar amount of the FICA taxes? Yeah, add them all up and subtract them from the total, right? So we get $1,065 billion. And there's two ways we can go about finding the percent over here. I would just take 100%, subtract those others. I believe that comes out to 32.8, not dollars, 32.8%. Any questions on that? Okay. Moving up number 4. Were you surprised to see the actual percentage for payroll taxes? So they're asking is, does this percentage actually surprise you? That's almost 1/3 of total tax revenues are payroll taxes. No opinions? Do you guys understand what the purpose of payroll taxes are? Okay. Well, your income tax refunds and stuff. Well, that what you're talking about there is individual income tax. There's money taken out for federal and state income taxes from every paycheck you get. And that's what you can get back is that refund on that. Sometimes you get back from both. Sometimes you get a refund from one and have to pay a little bit into the other. Sometimes you end up paying into both. Where you have to be careful is if you work multiple jobs. So each job takes out based on your income. But if working a second job puts you in a higher tax bracket, neither job knows about the other one, so they're withholding at a lower rate. So that's where you can end up having to pay money in. So you do have to be careful if you work multiple jobs. Yep. Yes. Yeah, there are non-resident benefits to the state income taxes. You can if you do it right, yes. Wisconsin actually has a slightly higher tax rate than Minnesota. So if you live in Minnesota, Wisconsin allows you to use the Minnesota tax rate instead of the Wisconsin tax rate. Now, corporate taxes, that shouldn't really affect you a whole lot. What that is, I shouldn't say it doesn't affect you, it does affect you. But that's large corporations like Sears and IBM and those are paying taxes on their profits. Now, when I say it affects you, it does affect you because that does affect the price of the items that you buy from those companies. If they pay higher taxes, of course, they're going to raise their prices. Other, like I said, that's like taxes on cigarettes, alcohol, taxes on gasoline are actually probably the largest that goes in that classification as excise taxes, the gas tax for your cars. Luxury taxes, like whenever you check into a hotel, might be advertised as $85, but you end up paying like $98. A big chunk of that is a luxury tax or excise tax. And then, of course, taxes on imports and exports and stuff like that, which we don't have a lot of anymore. So the big one is the FICA tax, and that's what this question is asking about. Is it surprising that the actual percentage of the FICA tax is as large as it is? But what the FICA tax is for two things. One is for Social Security. So when you retire, or if you become disabled and you can draw Social Security, that pays, that tax goes to pay for that. And the other is for Medicare and Medicaid. So that's the health care, the insurance for elderly or low-income people who can't afford other health care. So that's nothing to do with running the government. That doesn't pay for military. It doesn't pay for any of the senators or anything like that. It just pays for those programs: Social Security, retirement and disability, and then the Medicare, Medicaid, health insurance. So is it surprising to see that being 32.8? Again, almost 1/3 of total taxes. Guess not. Well, the thing is, a lot of people would think, well, that's really high. Partly because you only pay out of your paycheck about 7.63%. Oh, sure. Out of your paycheck, you pay about 7.63%. What it comes out to is you pay 6.2% of your paycheck goes for Social Security. And then 1.45 goes for the Medicare. I'm just going to say Medicare, Medicaid, and whatever. That's how much you pay. And then your employer has to match it. So what that does is that gives you a total, if you were to add those up and then double it for your employer match, 15.3% of every penny you earn goes for FICA taxes. Now your income tax rate, that can actually be anywhere from actually negative up to, I believe the highest tax bracket now is about 40%. Most people are paying around 12 or 15% for income taxes. But, we've mentioned refunds, and there are actually cases where, based on your status and your conditions, your refund can actually be larger than what you paid in for the year. So some people actually do have a negative income tax. So it might be surprising at first to see FICA taxes be 1/3 of all tax revenues. But as you think about it more, FICA is the one thing that everybody who works has to pay. And it's always the same percent for everybody. So as we go on, the original pie chart figures 1 and 2 were rendered in 3D. So now they're going to show you one that's in 2 dimensions. So this 2-dimensional one here in problem 5. Looking at it, do you think that is a more non-deceiving way of presenting that data, a more objective way of presenting the data? Well, as you look at it, what would you say? Well, now that we know that the payroll taxes, the FICA taxes, are about 1/3 of total taxes, does that 2-dimensional graph look more? Actually, they may not have actually given the 2-dimensional graph. They might be asking you to draw it, aren't they? They're asking you to sketch it. They didn't give you the picture that I have in my notes. So let's sketch it. Pretend that looks like a circle. And we have the individual income tax is 47%. So what portion of a circle is that? About a quarter, about a half? No, the individual income tax is 45 or 47%. So how big of just a little less than half. There we go. 47%. That's the individual income tax. Then the payroll tax or the FICA tax is about 33%, which we've said is about 1/3. So it's about like this. Which takes up most of the graph already. Then we have 9 and 11%, so that's going to be just slightly larger. The other is the 9%. And corporate is the 11%. So now looking at a graph like that, now my circle isn't very straight, but looking at that, it's a lot easier to see payroll taxes look like they're about 1/3 of the graph. Whereas looking back at those other 3D graphs given, they didn't necessarily look like 1/3. Okay, now the next thing we're going to do is we're going to look at problem situation 2 here with bar graphs. So what I want you to do is I want you to take a look at this, read through problem situation 2, and I'm going to have you discuss with each other or on your own, or answer on your own, however you want to do it. Questions 6 through, I would say we're going 6 through 10 here. And we'll discuss those again in about 4 or 5 minutes. Okay, let's take a look at these. So, number 6. What we have here, of course, we have the graphs of smartphone sales by year from 2011 to 2015. And this is what we call a stacked bar graph. We have all three numbers in a single bar. So what they're showing us here is in each bar, the bottom number, the bottom portion represents Android sales. The next portion is iOS. iOS is typically associated with what type of phone? Apple, good, the iPhone. And then the top one is others. Some of you may not necessarily remember there being others. The others would be for a while in like 2008, 2009, up through about 2010 or so. The Windows Phone was actually coming on strong, and it was predicted at one point that that was going to be the next big phone that was going to actually squeeze out Android. It was going to be just like in the computer market, it was going to be Windows and Apple. And so that was the prediction that it was going to be Windows and the Apple again. But it didn't work out that way. Android stayed strong. So anyway, for question 6A, how many total smartphones were sold in 2014? There's two ways we could go about doing it. You can just look at the top of the bar and go over to the axis and try to guess what it says on the axis, or it actually does give you all three of the numbers, and you can just add them up. What did you come up with there? If you add those up, what do you get? Perfect. That is millions, which would be equivalent to 1.244 what? Billion. There you go. You had it. Now, here's the bigger question. In 2014, what percentage of the smartphones were iOS? So iOS is the 191 out of the total of 1244. How did we find that percentage? 191 over 1244. Good, which gives us 0.1554. Yep. Or 154, I should say. So 15.4%. Good. Number 7. Out of the 5 given years, in which year was the percentage of smartphones for iOS the greatest? So they want us to find the percentage for each year. So in 2011, it was 89 out of, oh boy, 472. So that gave us 18.9%. Is that look right to you guys? So in 2012, it was 129 out of, was that 675? 19.1%. And in 2013, it's 151 out of 968, down to 15.6%. There was 15.4% we got in 2014. So we just need to do 2015 yet, which is 226 over, what's that total up to? I believe I get 1422, which is 15.9%. So what year was the percentage of iOS phones the largest? 2012, the 19.1%. So here's the question. Can we conclude from these numbers? Now I want you to think about this very carefully. Do these numbers show that maybe the iPhones have peaked and are falling off? Okay, yes. If we look at it, if you wanted to number it from 15, 16, 17, 18, 19, we go 2011, 12, 13, 14, 15, the graph would look something like this. 18.9, 19.1, 15.6, 15.4, 15.9. So it does show a major fall between 2012 and 2013, but it looks like it might be on a slow climb back up now. The one thing that's definitely shown in this graph, though, is what is slowly disappearing. It looks like the others we can safely say are slowly shrinking, right? Okay. So now, from 2012 to 2013, what was the absolute change in the number of smartphones sold? Well, to get that, we would add up those numbers in the bars and subtract the totals. Well, we've already found those totals. Doing the percent, 2012 was 675, 2013 was 968. So the absolute change was how much? If we subtract those, they get 293, right? What's up? Okay. Okay, for part C then, what is the relative change? Relative change. You guys remember how to do relative change? This is a formula you've given a couple of times, Sarah. Remember, it is new minus old over old, yes. So in your notes, find that relative change between 2012 and 2013. So we divide that out, we get 0.434, which is 43.4%, right? So that's the relative change in all smartphones. How about just for iOS? So for iOS, it was 151 minus 129 divided by 129. What does that give us for a relative change? They give us 17.1%. Okay, perfect. So what we see is the number of, that Apple iOS operating system is increasing, but not nearly as fast as the total number of smartphones is increasing. So between 2012 and 2013, let's see, we already did that. Now that you have examined some details about the stacked bar graph, consider the whole chart. What is the main story behind the chart? In other words, what are the main trends? What are the main trends the chart shows? Well, we've already discussed a lot of this. First of all, total smartphones. What can we say about the total number of smartphones being sold each year? It is rising, and relatively consistently. The percentage of rise might be going down, but that's only because the number is getting larger. But it looks like it's going up by about 200,000 a year, pretty consistently. How about Android phones? What can we say about the sales of Android phones? Rising quickly or slowly? Yes, they are a rapid rise. How about iOS? Okay, so you'd say rising steady. So it's not really slowly, not really quickly, but there's kind of a consistent, steady rise. That's a good way of putting that. And then finally, other. Definitely decreasing. Perfect. Okay, it's about 11:22. Let's take a quick break. Let's do 8 minutes, and we'll come back at 11:30 and we'll start up again. Okay, we've got everybody back. So now, 9 and 10 are really the big problems for this one. And for number 9, what it's asking you to do is to create a bar chart. But rather than doing a stacked bar chart, it wants you to create what's called a double bar chart. And the double bar chart has 2 separate bars. And what it's going to be here is the first bar, well, for each year there's going to be 2 bars, I should say. And for each year, the first bar is going to be Android. And the second bar is going to be iOS. So I want you to take the data from this and I'll help you organize it here into a little chart so it's easier to put in. In 2011, there were 220 million Androids and 89 million iOS phones sold. In 2012, it was 447 million Android and 129 million iOS. In 2013, there was 759 million Android phones and 151 million with iOS. 2014, it's just over a billion, 1.004 billion or 1,004 million Android phones and 191 million with iOS. And in 2015, we had 1.161 billion. So that's 1,161 million Android phones and 226 Apple phones. So I want you to construct a bar graph with those numbers in it. Now, 2 things when we make a bar graph that we have to consider. The first one is always the smallest number. So out of this whole table, what is the smallest number we have to represent? Careful, 89, there we go. 89 is the largest number. What's the largest number we have to represent? 1,161, okay? So now from that, we have to determine a scale. We have to go from 89 to 1,161. So if we go by hundreds, this would be just less than 100. This would be just less than 1,200. So it looks like if we take and we number by hundreds from 100, 200 up to 1,200, it should work. So I'm going to have you sketch in your notes a double bar graph for that data. Like I said, for each year, there'll be two bars. There'll be the Android bar and the iOS bar. So I'll give you about 6 or 7 minutes to sketch that graph, then we'll talk about it. Do we have our graph made? Now to make this simpler, I'm going to do it in Excel. On the homework assignments, if it'll allow you to insert an Excel document, you're more than welcome to do that. So let's do the year. Androids, we have 220, 447, 759, 1004, 1161, iOS 89, 129, 151, 191, and 226. Okay, so column chart is what we're looking at here. And we're just going to do a simple double column chart just like this. We'll have to do some adjustment here. Let's see here. Select data. That's what I want. So the year is going to be removed, and let's do that. There we go. So the years didn't come through on the axis down here, but we've got the basic chart. Does that look like what you guys sketched out? Or where you were going with it if you're sketching them out? Okay. So what we were saying earlier does coincide here. And the point well, actually, I shouldn't say the point. If you look at this long enough, what you might see, trying to look here to see if they have there it is, my shapes, is if I take a line here and stretch it across the top of the Android, you can see it's relatively close to the top of those bars. And if I do the same thing for Apple, I get about the same thing. Both of them are an approximately linear relationship. And if we have a linear relationship, what are the two things we need to know for a linear relationship to construct a linear model? So remember, if we have a linear model, it looks like a line on our graph like that. We have the equation of y equals mx plus b. What does m represent? the slope. And remember, slope is a rate of change. What does B represent? A y-intercept. And remember, y-intercept represents a starting value. So if we wanted to construct a model for each of these, for Android and for iOS, we need to know those two things. The first thing is the starting point, or starting value. For Android, with the data we have here, what would be the starting value? How many Androids were sold in the first year? In 2011, how many Androids were sold? 220. Very good. So that would be our starting value. That's going to be our y-intercept. That's our B. Now we need to find the rate of change. Now it's not going to be exactly the same rate of change every year here because it is real data. It does vary a little bit. So what we're going to find is something called an average rate of change. An average rate of change is the average change per year. So the first thing we have to do is find the yearly change. So I want you to do this quick in your notes. Find the change from 2011 to 2012. Not a percent, just the absolute amount. How much is it? So you're just going to subtract. Then from 2012 to 2013, the change. 2013 to 2014. And 2014 to 2015. So to do the 2011 to 2012, 2012 is 447, 2011 is 220. That's a change of 227. So I want you to find that for all the other three. So quickly in your notes, calculate those out. Okay, so for 2012 to 2013, they went from 447 to 759. So 759 minus 447 is 312. Perfect. Then went from 759 to 1004. 1004 minus 759 is 245. And then it went to 1161 minus the 1004, which is 157. So then how do we find an average of those numbers? Okay, I'll race you to it. Let's work on finding the average. See if you can get it before I do. $235.25. Is that what everybody gets? Okay. So the equation, the model that would model Android phone sales would be y equals, now I tend to put the y-intercept first. So my y-intercept would be the 220, which was the first year's sale in 2011, plus that rate of change of 235.25 phones per year times whether you want to use X or T or whatever, I'll put in X and define X as years after 2011, because 2011 was our first year. Now, looking at these changes here, do you think this model would be good at predicting if I asked you to predict 2016 sales, do you think it would do a good job of predicting 2016? It'd be close, yes. It's not going to be exact. What number would I put in for X? Well, 2011 would be year 0, right? So 2016 minus 2011 is 5. So let's try that. Times 5. I'll put it in parentheses. So if we multiply that out, 220 plus 235.25 times 5 gives us 1396.25. So yeah, about 1396, 1397, which would be fairly consistent with the increases we've seen. Now, do you think it would be accurate if I tried to use it to predict 2025 sales? Great answer, Britta. Perfect. It's further away. The 2016 was the next year. Generally, we can use to predict for a year or two, but we usually don't want to go too far for a couple reasons. One, we can see these changes here, we're staying relatively consistent around that 220 to 250 mark. We had a slightly high one here at 312 and a slightly low one here at 157. We don't know if those are going to be just, if that's a trend or if it's just a little bit of a deviation. If we went another year, if we had the data for 2016, and let's say that we found 2016 sales were $13.99. That would allow us to then add a rows to this chart. 13.99 minus 11.61, which would be 238. If that were the case, that would be showing us that yes, our average is still that 220 to 250 every year, but some years it's a little higher, some years it's a little smaller. But the other case might be, let's say that the 2016 number, oops, get out of there, came in at $12.98. Then the difference would be $12.98 minus $11.61. That would only be $137 difference. That would be indicating that maybe the increase in sales peaked here and they're starting to drop as we go further into the future. So yes, we can use it to predict a year or two in advance, but if we go much further than that, there might be small trends going on here that we can't quite see or we can't predict. The other thing is, if we go more than a year or two into the future, there might be some incredibly easy to use new operating system for smartphones that comes out that just totally takes over the market. We can't predict that. So those of you that go on to take statistics at some point, that is an important part of this. Now, what we did here creating this linear model was just a simple linear model. In statistics, we'll look at more complex models called linear regression models, which a little bit more complex work, but we use technology to help us with it. But they do a little bit more of an exact description of the data. But they have the same weakness. They can only predict so far ahead before it becomes very unreliable. Okay, what I want you guys to do now then, using our numbers here for the Apple operating system, the iPhone operating system, I want you to do the same thing. Create the linear model, just like we did here, where we found the starting point, that first value, and then we found that average rate of change. So I'll go back, so you got the table here to use. Create that linear model. I'm going to give you about 7 or 8 minutes here. So a little afternoon, we'll talk about, see how your model is coming and see what you come up with. Okay, let's see how the model is working out for you here. So of course we've got that initial value, that starting value of 89. So that's our y-intercept. So for our average rate of change, for 2011 to 2012, what was the change? 40, exactly, perfect. From 2012 to 2013, the change was 22. From 2013 to 2014, what was the change? 40 again. And from 2014 to 2015, what was the change? 35. Perfect. So then the average rate of change was 34.25. Perfect. So what does that give us for an equation? (34.25x plus 89). And again, x is years after 2011. So now that we're there, I'm going to have you predict what would be the iOS sales in 2017. I'm going to give you, 30 seconds to figure that one out quick. So what'd you get? 294.5. Okay. What'd you put in for X to get that? 6. Good. 2017 minus 2011 is 6. So yes, about 294.5 sounds pretty reasonable. Okay, so the main points we wanted you to take out of today. When it comes to graphs, there are a couple of things. One is they can be misleading. What were some of the things that we did that made graphs misleading? 3D. Yes, very good. 3D graphs. with the pie graphs, making them 3D, pie or circle graphs. Even with bar graphs, it gets done with bar graphs as well, where they use the 3D effects on bar graphs, and that can be the same way. It can make it very misleading. Another thing that gets done that we didn't really explore in this unit, but we talked about last Monday, is the broken axis. That's mostly on bar graphs or line graphs where they do this thing, and instead of numbering from 0 on up, they might start at 1,000 and number something like this. So now you have things like this where B looks like it's twice the size of A when it's really, this is like 1,002 and that's like 1,021. The other thing that's a weakness of bar graphs, actually of any graph, I should say, is exact numbers. All the graphs we looked at today actually had the numbers written in. So they might have it written in as 1,002 and 1,019 or whatever that ended up at. But if those numbers aren't written in on a bar graph, looking at them and trying to trace them back to the axis and get an exact number can be somewhat difficult. So finding the exact numbers is a weakness. The biggest strength of graphs, though, one is, of course, quick reference. If you wanted to know which number was the largest, either a bar graph or a pie graph would find that rather quickly. The bar graph, you see the tallest bar. In a pie graph, the biggest wedge. Now, the one I sketched here, it might be kind of iffy which one of those two is the largest, but usually you can see the largest rather quickly in a graph. The other thing that we saw that the graph was good for was showing patterns. If we have several graphs over time, you can see whether pieces of the graph are growing or shrinking. The other one that we saw in the smartphone operating systems was we saw that we were actually able to create that linear model. Once we graphed it, we saw that those were both approximately linear, and we created a linear model. But we could have also, now that we know how to create it, we may have found an exponential model in those. We may explore exponential models more in the next month or so. We're not going to get into them too much right now. They're a little bit more complex to create the exponential models. Rather than finding the absolute change from one period to the next, you've got to find a percentage change, a ratio from one period to the next. Which, like I said, we may, if we get time, we'll look at that in the next few weeks. So for tomorrow, or not tomorrow, for Wednesday, I would like you to work on the out-of-class exercises for S1, and then the P&L for S2. Those technically are not going to be due until Thursday, but we'll have time. We'll need the P&L, of course, for Wednesday's class, and we'll have time to answer any questions on the out-of-class exercises on Wednesday so that you can get those turned in by Thursday. Anybody have any questions? Okay, well, we're about 9 or 10 minutes early here, but we don't have anything else to do for this unit. So I'll let you guys off the hook. If you want to get started on some of the problems and let me know if you have any questions, that's great. Otherwise, we will see you on Wednesday. You bet.